Hello everyone, welcome back again to Embed System course. So we are in chapter number 2, that is 8051 timers and serial port programming in a C. As I told you, there are two parts in this chapter. Part 1, under this we are going to study 8051 timers programming in C, and in part number 2 we are going to study serial port programming in C. Okay, so we are in lecture number 3. We were studying part number 1, that is timers programming in C. Okay, so we studied about 8051 timers, in particular mode 1, and we also uh, saw few programs in mode 1 to generate time delay, precise time delays. Okay, so that happens in previous lecture number, uh, I think 2. And in this lecture, we are going to study mode 2 of timer 0 and timer 1 of 8051 microcontroller, and mode 2 is auto reload mode. Okay, and by using this mode 2 we are going to generate time delay. So we will see programs on that. So let us start with mode 2. Okay, so this is a block diagram of mode 2 of timer 0 or timer 1 of 8051. Okay, if you compare this block diagram with block diagram of mode 1, okay, so up to this part, okay, so this part, that is same. Okay, so uh, timer clock frequency is derived from oscillator that is connected to 8051. It gets divided by 12. Okay, and that frequency, acts as, that is f oscillator divided by 12, okay, as timer clock frequency. Okay, so these pulses of frequency f oscillator divided by 12, okay, so these will uh, start reaching at the output of this gate if tr bit is set. Okay, so timer 0 is having tr bit 0 and timer 1 is having tr bit 1. Okay, so if we set this bit, means this gate will be enabled and these pulses will start reaching at the output to the further logic diagram of timers. Now in mode 2, which is called as 8-bit auto reload mode. Okay, so this mode is 8-bit. So as in mode 1, th and tl both registers are used. Okay, but here only one out of tl and th, only one uh, timer register is used, and that is tl. Okay, means count in tl will get incremented due to these pulses. Okay, and for that we have to also use a higher order timer register, that is th. Okay, so th should be initialized with initial count value. Okay, that is derived to get desired time delay. Okay, and that should be loaded into this th register. Okay, so once we load that initial count into th, that will automatically loaded into TL. Same count will get loaded into TL. Okay, and when you turn on this gate, or if you turn on this timer, okay, for example, timer, suppose timer 0 we are using. If we set bit TR0, then this gate will be enabled and these pulses will start reaching at the output of this gate, and it will, due to each pulse, okay, so these pulses will get applied to this tl register. Okay, in right now we are assuming timer 0, so this will be tl0 and this will be th0. Okay, so these pulses causes to increment count in tl0. Okay, and what is count in tl0? When we load some count in th0, that will get automatically get loaded into tl0. Okay, so that count will start incrementing due to pulses it is getting here. Okay, with each pulse count in tl0 will get incremented by 1. Okay, so this tl0 count can go maximum up to f Okay, so it will go to FF, and due to one more pulse it will become 0 0. So this is called as rollover of count. So count in TL0 when becomes FF, and due to one more pulse it again becomes 0 0. So this is called as rollover of count from all ones to all zeros, or FF to 0 0 in TL0. When this happen, this will set this TF bit, in particular TF0 bit, because we have assumed timer 0. Okay, so it will set TF0, that is timer flag, timer 0 flag, it will get set. Okay, and after that, when TF0 flag will get set again, this will also causes to reload count in TL0 into TL0 automatically. Okay, so automatically after TF0 flag bit gets set, means count in TL0 becomes 0 0. Again, whatever value that we loaded into TL0, okay, that will get loaded into, automatically get loaded into TL0. Okay, and after that we have to make this TF0 flag bit 0. Okay, and again, if we haven't stopped this timer by resetting TR0 bit, again count in TL0 start incrementing from that initial value. Okay, so here 8-bit auto reload mode means it is 8-bit, only one timer register is used, and count, initial count in this TL0 gets auto reloaded from TS0, means whatever value we loaded into TS0, that will be fixed. Okay, once we load it, and that will get automatically reloaded into TL0 when TF0 flag bit becomes 1. Okay, means whenever count in TL0 rollers from FF to 0 0, then TF0 flag bit will get set, and that causes to auto reload of count in a TL0 from TH0. Okay, so this is called as 8-bit auto reload mode. Okay, now whatever we discussed, that is written here. So mode 2 is an 8-bit timer mode. So it allows only values of 0 0 to FF to be loaded into timers register THX. So as I told you, in TH0, TL0 and TH0 are of 8 bits. Okay, so count in TH0 could be only in between 0 0 to FF. We can load value in between 0 0 to FF into TH register. Okay, after TH X, means TH0 or TH1 is loaded with 8-bit value, the 8051 gives copy of it to TLX, means whatever value first time we load into TH0, okay, so that value will get automatically copied, okay, copied into TLX. Okay, then timer must be started using TRX bit. Okay, after timer is started, it starts count up. Okay, so count in timer register always count up due to pulses it is getting. Okay, so it starts count up by incrementing the TLX register. It counts up till it reaches its limit of FF. When it rollovers from FF to 00H due to next pulse, that is called as a roller of count from all ones to all zeros, that is FF to 00, it sets high the TFX flag bit. Okay, after that TLX is reloaded automatically with the original value kept by the THX register. Okay, so whatever value we loaded in THX register, that is there, so that will get automatically reloaded into TLX register. Okay, when this happens, when TFX flag bit gets set. To repeat the process, we have to simply clear TFX. Okay, now see the difference. There is no need to stop the timer. Okay, only we have to clear the TFX bit, because that initial count value is already automatically loaded into TLX. Okay, so to repeat the this timer, means to generate same amount of delay, we have to just clear TFX flag bit. Okay, so this makes mode 2 as an 8-bit auto reload mode. Okay, now what are the steps in programming this timer 0 or timer 1? Okay, so here should be timer 0. So here not here timer 0 or timer 1. Okay, so what are the steps involved in generating time delay? Okay, using mode 2 of timer 0 or timer 1 of 8051 microcontroller. These steps are given. We have already discussed these steps. Okay, so first what we have to do, load the TMOD register with the value indicating which timer is to be used in mode 2. That means either we are going to use timer 0 or timer 1. Okay, in mode 2. According to that, we have to load TMOD register with a proper value. Okay, then step 2 is load THX with initial count value. So that depends on how much time delay you want to generate. Okay, that value you have to load into THX. Okay, then start the timer. So how to start the timer? Uh, you have to just make tr bit. Okay, trx bit, you have to make it 1. Okay, so that bit you have to set. Okay, trx bit you have to set. After that you have to just keep monitoring the timer flag bit, that is tfx bit, which is um, in a tcon sfr. Okay, to see if it is raised. When tfx bit will get set when count in tl. Okay, because when we start the timer, count in tl will start incrementing. Okay, when you turn on timer, these pulses will start reaching at the output of this gate, and count in tl0 will start incrementing from whatever initial value that is loaded from this th register. Okay, so count in TL0 will start incrementing from initial value due to each pulse it is getting. Okay, so that is happens when you start the timer. And after that, what is your job? You have to just monitor TF flag bit. Okay, because whenever count in TL0 rollovers from FF to 00 or all ones to all zeros, then TF0 flag bit will get set. So next step is just to keep monitoring when that rollovers happens, because after that TFX flag bit gets sets. Okay, which is in tcon sfr. So uh, you have to continue monitoring until TFX flag bit will get set, and if it gets set, okay, then you have to get out of the loop. Okay, if it is raised, then clear the tfx flag bit. So whatever, so this flag bit gets set, we have to just clear tfx flag bit. Okay, for next round. And before that, what automatically happens, count initial count we have loaded. Okay, initial count we have loaded in thx, that will get automatically loaded into tlx. Okay, so this value will get loaded into, automatically get loaded into tlx. Sorry, this pen is not working properly, so let me erase it. Okay, so this when tfx flag bit will get sets, whatever value we have loaded into thx, that will get automatically reloaded into tlx. Okay, and then we have to clear the tfx flag bit for the next round and go to step 4, that is this, keep monitoring the timer flag, because this mode 2 is auto reload, means we don't need to reload tlx, it automatically get loaded from thx. Okay, so these are the steps involved in generating time delay in mode 2 by using timer 0 and timer 1 of 8051. Okay, now we will see the programs. So first program. Okay, so this is a program on mode 2. So write an 8051C program to toggle only pin P1.5 continuously every 250 millisecond. Okay, use timer 0 mode 2 to create the delay. Okay, so that is 8-bit auto reload mode. So what we have to do, we have to toggle. Okay, so pin number 5 of port 1 after every 250 millisecond. Okay, so that means we have to generate a delay of 250 millisecond by using timer 0 mode 2. Okay, So we have to use mode 2 of timer 0. So for that program is written. So see here, hash include reg51.h void t0m2 delay. So this is a function declaration of function name t0m2 delay, that is timer 0 mode 2 delay, because its definition is coming afterwards, that is after main function, from which from where we are calling this t0m2 delay function. Okay, then s bit my bit is equal to p1 caret 5 semicolon, means I am declaring my bit as s bit type of variable, and which is representing pin number 5 of p1. Okay, means due to this statement, address of pin number 5 of port 1 will get assigned to my bit. That means by we can refer this pin number 5 of port 1 just by using this symbol, that is name my bit. Okay, then main function void main void, in between opening and closing braces, unsigned char xy semicolon. I am declaring x and y as unsigned char type of variable, means in which I can have value in between 0 to 255. Okay, so that is the meaning. While one means here this is infinite loop, means whatever statements are there in between this opening and closing braces. Okay, that means in loop, while loop. So these statements will get continuously executed. Okay, now see what happens. My bit is equal to tilt my bit, means just tilt is inversion operator, that is not operation. So previously if my bit means pin number 5 of port 1, if it is 0 it will become 1, and that will get assigned to my bit, means toggle. This is just toggling of pin number 5 of port 1. Okay, means previously if it is 0, now it will become 1. Previously if it is 1, it will become 0. Okay, just toggling operation. Then these are two for statement. Okay, nested loop, for loop. Okay, so see what is function of these for loops. So for x is equal to 0, x is less than 250, x plus plus. Okay, and in this for loop, for y is equal to 0, y is less than 36, y plus plus. Okay, and t0 m2 delay. Okay, now the here t0 m2 delay function we are calling. Okay, how many times? So inner loop will be executed 36 times and outer loop will be executed 250 times. Okay, means this t0 m2 delay function we are calling how many number of times? 36 multiplied by 250. Okay, now that is because we want 250 millisecond delay. Okay, and this 250 millisecond delay is not possible by using this mode 2 of timer 0. This is large delay. Okay, so we are calling this function t0m2 delay, which is generating a fraction of 250 milliseconds. Okay, and we are generating 250 millisecond delay. How we are going to study? First we have to see how much delay this t0m2 delay function is generating, in which I'm using mode 2 of timer 0. So t mod is equal to 0x02. Okay, so when this function gets called, what will happen? Control will transfer from here to this function definition, and this function will be executed. So what is in function t0m2 delay? So first t mod is loaded with 0x02. This will configure timer 0 in a mode 2. Okay, then th0 is equal to minus 23. Minus 23 is the number we are loading into th0. Means actually what happens? 2's complement of this 23 will get loaded into th0. Okay, now see why we have put here minus 23, or what will happens when th0 will get loaded with minus 23. Okay, so see here, in th0 what value we are loading? That is 2's complement of 23. Okay, means 23 first complement plus 1. Okay, so that is this operation. Okay, 2's complement of 23, we have to just subtract it from ff. Okay, so it is actual decimal. Okay, ff minus, that is a xx xx plus 1. Okay, so xx is what? That is a hex equivalent of 23 that will get subtracted first from FF. So this is a ones complement. We are taking ones complement. Okay, if we subtract FF, that is XX from FF. Okay, so I will get XX ones complement, and I'm adding one into it, means I'm getting two's complement. Okay, so actual number I'm loading into TH0, that is decimal equivalent of number I'm loading into TH0 is 233. Okay, so this 233 when we load into TL0, that will also get copied into TL0. Okay, so mode 2, if you remember, so whatever value we load into TH0, that will get copied into TL0. So we are loading 233 here into TH0, that will get copied into TL0. Okay, so that is the thing. So after loading TH0, copy of that number will get sent to TL0, means right now TH0 and TL0 are having value 233. Okay, then a TR0 is equal to 1, means I am turning on timer 0. What will happen? Count in a TL0 will start incrementing from initial value 233. Okay, and after that I am just monitoring TF0 flag bit. Okay, right now it is 0. So here, no, not this. This is the program. Sorry. Okay, I'm monitoring TF0 flag bit until it becomes 1. When it becomes 1, I will come out of loop and I will go to next statement. When TF0 flag bit will become 1, when count in TL0, okay, reaches maximum, that is a FF, that is 255. Okay, and due to next pulse, when count becomes 00 in TL0, then TF0 flag bit will get set, and it will come out of loop and go to the next statement. Here TR0 is equal to 0, we are turning off the timer 0, and TF is equal to 0, we are clearing off TF0 flag bit which was set. Okay, and control will come back to the main program. Okay, so this thing will happen when this T0M2 delay executes for once. Now how much delay it is generating? So for that, what is formula? So here initial value we have loaded is 233. Okay, so that we have to subtract from FF. Okay, that is the formula. Okay, that is in decimal, we have to subtract that value 233 from 255, that is FF, and we have to add 1. Okay, so again we will get number 23, which will get multiplied by 1.8085 microsecond, assuming that F oscillator frequency is 11.0592 megahertz. So time period of F oscillator divided by 12, which is acting as timer clock frequency, is 1.085 microsecond. Just multiply it by 23, so that is giving me 25 microsecond. Okay, now if this one function call to this T0M2 is generating 25 microsecond to generate 250 millisecond, so 25 microsecond multiply by 250 multiply by 40, that will become 250 millisecond, means this 25 microsecond function we have to call how many number of times? 250 multiply by 40. Okay, so here first for loop is here 250, it is repeating 250 times. Okay, and second for loop it should repeat for 40 times, but I have taken it 36, means 4 less, because here instead of 40 I am putting 36, because so overheads due to these two for statements, okay, are there, means to execute these two for statements it requires some time. Okay, so if I put here 40 instead of 36, what will happen? The delay that will get generated may be greater than 250 millisecond. Okay, so to compensate for that, I have decreased this count. Instead of 40, I have put here 36, so that it will approximately generate 250 millisecond delay. Okay, so what is use of this nested to for loops? Just to repeat this T0M2 delay function call to 250 multiply by 36 times, so that it will generate 250 millisecond delay. Okay, so when this T0M2 delay function called 250 multiply by 36 times, after that again control goes to this statement. My bit is equal to again complement my bit, means initially if it is 250 millisecond, and if my bit is 0, so this my bit will remain for 250 milliseconds. Okay, so this will remain 0 for 250 millisecond, and then it will become 1. Okay, again this call to T0 M2 delay repeated. How many times? 250 multiplied by 36 times, generating again 250 millisecond delay. But now we have complemented this my bit, means it will remain 1 for again 250 millisecond. Again after that, again control go backs, again this will be complemented, again this bit will become 0, again it will remain 250 millisecond. Okay, again it will become 1, and so on. Okay, so we are toggling my bit, that is pin number 5 of port 1, continuously after 250 millisecond delay, and this delay we are generating by using 8-bit auto reload mode of timer 0, that is mode 2. Okay, so this is first program, and next program, write an 8051C program to create a frequency of 250 hertz on pin P2.7, means on pin number 7 of port 2 we have to generate 250 2500 hertz frequency square wave. Okay, and for that I have to use timer 1 mode 2. So 2500 hertz frequency means its time period is 1 divided by 2500 hertz, that is 400 microsecond. Okay, and so I have to generate square wave like this, whose frequency should be, sorry, so I have to generate such square wave of 2500 hertz, means its time period will be 400 microseconds, that is this time period is 400 microsecond, so this is 400 microsecond. Okay, and this will be how much? Half of that, so this will be 200. Okay, so this will be 200 microsecond, means we have to generate delay of 200 microsecond by using timer 1 of timer 1 in mode 2, that is 8-bit auto reload timer mode. Okay, so and we have to just toggle pin number 7 of port 2 in between. Okay, so for that program is written C include reg51.h void t1 m2 delay void. This is function declaration of function, that is t1 m2 delay means timer 1 in mode 2 delay. Okay, so its definition is written here. Okay, then s bit my bit is equal to p2 caret 7. I am declaring my bit as s bit type of variable, which is representing pin number 7 of port 2, means due to this declaration statement, address of pin number 7 of port 2 will get copied into my bit, so that I can represent this pin number 7 of port 2 by using symbol or variable name my bit. Okay, then this is the main function void main void unsigned char x. I am declaring x as unsigned char type of variable, and then this is infinite while loop. Continuously the statements in the loop will be executed. Okay, so in that is statements in between opening and closing braces, there are two statements. So my bit is equal to tilde my bit, so this is just inversion or not operation on my bit. My bit is pin number 7 of port 2, so if previously it was 0, it will become 1. If previously it was 1, it will become 0. Then I am calling t1 m2 delay function. Okay, so after this control will get transferred to this t1 m2 delay function. So see what is written in t mod is equal to 0x20. So when I load this 0x20 into t mod, timer 1 will get configured in mode 2. Okay, because we are using timer 1 mode 2, so we should configure timer 1 in mode 2. So that we are doing by loading 0x20 into t mod. Then th1 is equal to minus 184. So how this minus 184? So minus 184 means we are actually loading what? 2's complement of this. Okay, so 2's complement means minus 184. That 184 will get, that is the hexadecimal equivalent of 184 will get subtracted from FF, and 1 is added, and that value actually get loaded into TH1. Okay, now if I load minus 184 into TH1, that will get also copied into TL1. Then we are turning on timer and we are waiting for TF flag bit of timer 1 get sets. When it gets set means value in TL1 rollovers from FF to 00. Okay, and then we are stopping timer, we are clearing TF flag bit, and we are going back again. Now how much time delay this time delay is generating, so that we can calculate. Okay, so just by uh, okay, so for that, um, for this 200 microsecond, what count we should load into th1, that is calculated. So for 200 microseconds should be divided by 1.085 microseconds. So there are 4 steps to derive the initial value to be loaded into timer register for desired time delay. So what is first step? Divide that desired time delay, that is 200 microsecond, by 1.085 microsecond, because we have assumed f oscillator 11.0592 megahertz. So timer clock frequency is that is 11.0592 divided by 12, and its reciprocal is its time period, that is 1.085 microsecond. So we have to just divide this desired time delay by 1.085 microsecond. After that, whatever count comes 184, we have to just uh, subtract it from FF, or 255. Okay, 255 minus 184 plus 1 minus 184 plus 1. Okay, or FF minus 184 plus 1. Okay, so whatever count we are getting, okay, that is XX in hex, that we have to load into th1. Okay, so that means actually 184. Okay, we have got 184. So what we are doing here, this is actually 2's complement. Okay, so instead of deriving this value and loading into th1, simply what I can make, I can just add minus before 184, and that value I am loading into th1, means automatically internally what is happening, 2's complement of this 184 is being loaded into th1. Means what, actually this operation 255 minus 184 plus 1, and whatever value that will get loaded into th1. Okay, so for 200 microsecond, I have to load this excess value into th1, and that value I am loading into th1, that will get automatically copied into TL1. And when we start that timer, okay, from that initial value, count in TL1 will start incrementing. When that count rollovers from all ones to all zeros, means FF to 00, TF1 flag bit will get set. Then we will come out of loop, we will turn off the timer or stop the timer 1, and then we will clear TF1 flag bit, and again we are going back to this, that is my bit is equal to inversion my bit, means we are making first, initially if it was 1, we are making it 0. Okay, in this way we are toggling this pin 7 of port 2 continuously, and in between we are calling time delay of how much, that is 200 microsecond. In this way we are generating square wave of frequency 250 hertz at pin number 7 of port. Okay, so in this way this program is generating square wave of 2500 hertz. Okay, at pin number 7 of port. Okay, so this is the program which uses mode to generate such square wave. Okay, and we have employed timer 1 for that. So actually my pen tab is not working properly, so that I couldn't write properly here. Okay, but okay, next time I will correct that. Okay, so this is about mode 2, that is 8-bit auto reload mode of uh, timer 0 and timer 1 of 8051, and we have used that mode 2 to generate time delay, precise time delay. Okay, so thank you very much. Okay, so if any queries, we will uh, discuss in our live session. Okay, thank you.